Hi all. Right then, today I received a question. I got a question from a fellow coiler about how to find, or an easy way to find the resonant frequency of a secondary coil. So, without further ado, let's explain the situation. First of all, you will need a function signal generator, a scope, and of course, the coil itself. I have actually added the digital multimeter there set on the frequency range, because you can use that if you haven't got a scope. So what you need to do is, first of all, you connect the positive output from the signal generator, I don't think you can see that in there, to the base of the secondary coil. Okay, you then fix the oscilloscope probe. That's about say 6 inches away from the coil. A bit of a bodge job, I know, but never mind. And then you connect the ground of the signal generator to the ground of the scope probe, and that's all. That other one is the ground to the digital multimeter there. Okay, so I know that the running frequency of this coil is 660 kilohertz, but for visual purposes I've turned it down. So what you've got there, I've got that set on, I don't know if you can see that okay, I've got that set on 646 kilohertz as a starting point, sine wave, and you must have this on maximum output power, which on this Fieldtex function generator is 20 volts. You don't want to go above 30 though, because that can become a bit dangerous. Okay, and I've got my scope set up there. What's that on? Oh no, it doesn't matter, the scope's set up ready. Okay, so what you do then is, you can see that at the moment the scope is picking up a signal from the coil at 646 kilohertz, and if I move my hand closer to the coil you can see it changing, so you know the coil is actually transmitting that frequency. So now what you do is you gradually increase the frequency on the signal generator. So that's at 646, 647, 648, etc. Now I'm going to carry on increasing that, but I'm going to show you the scope, what's happening with the scope. So as I'm increasing the signal, you'll see the signal on the scope getting bigger, growing. Okay, that's at 656, 657, 658, it's still growing, sorry about the shakiness of the camera, 659, 660. Now try and balance this, try and stop that shaking a bit, that's better. Now if I go to 661, watch what happens. Did you see that drop? That's the frequency, the frequency dropped there, or rather yeah. Now if I bring it back up to 660, you'll see that come up again. Now if I go to 659, it drops slightly. Yeah, so what you're looking for is that peak. So when it gets to the peak, if it drops, you've gone too far. That's 661 kilohertz. That's too far. That's 660, that's the peak, and that is the optimum running frequency of the coil, 660 kilohertz. Now you can tell that it's transmitting, because I'm now moving my hand closer to the coil and absorbing the frequency that it's sending out. See the signal is sending out. I'm touching the coil now. Now move my hand away. You see that? So that's what you're looking for. Now if you haven't got an oscilloscope, you can use the digital multimeter set on the hertz or the frequency range. Now the output from my signal generator is as you can see 660 kilohertz. So the digital multimeter is about 0.3 kilohertz or whatever out, 659.7. Now, yeah, it's not exactly spot on, but it gives you a good ballpark figure. So again, what you're looking for is just a drop in the frequency, or a drop in the display, or a peak, if you get what I mean. When that display shows a peak, that is the signal, that is the frequency your coil is running at. Okay, so I'm going to drop, just to show you one more time, I'm going to drop the frequency down, the output frequency of the generator, see, it's decreased. Now I'm going to bring, that's at 648 kilohertz. Now I'm going to bring it back up again. And it's climbing, 659, 660, 661, and you saw that slightly drop. That's too far. Bring it back a point to 660, and there it is. Okay, so that's how you do it. Now remember, if you don't have a scope, you can use the multimeter. And the multimeter basically takes the place of the scope. So you'll have the negative of the multimeter connected to the ground of the signal generator, and the positive of the multimeter is literally floating, just the same as the oscilloscope probe. Okay, that is picking up the signal, and in fact it's quite impressive because it's picking up the signal from about 3-4 feet away, and it still hasn't changed. Okay folks, I hope this helps. Any questions, please let me know, and happy coiling. See you later.